Web agents are at an inflection point. In the past few months, a lot of the technology that's needed to get these things really good, whether that's remote browser instances that spin up in under a second, or the models themselves, have gotten good enough that this technology is starting to become usable, but it's not fully there yet. And I kind of want to explain why. And I want to explain how to build applications with web agents. So this is the first part of a few part series. Before we dive deeper into web agents, let's get a good understanding of what an agent is in general. Anthropic has this really good article called Building Effective Agents, where they sort of highlight the specific terms that we're going to use from here on out. And there are two sorts of agentic systems. One is workflows, and the second are agents. And the agents part of what we're going to focus on. People get this language completely confused. I got it confused, so I just want to explain this. Workflows are just systems, just you know, Zapier or Gumloop, if you're familiar with those things, where they have a defined set of flows, you know, get this data from Google, process it in this way, send it to this place. They're very predefined, whereas agents sort of define their process on the fly using an LLM, of course. So you can see here, this is a good example of a workflow. You have an input, maybe that's an instruction, it calls an LLM. You take an output, you do some sort of logic, and then you decide what step to do next. All of this is predefined ahead of time, whereas an agent is more of a loop. So this is from a later part of this Anthropic article, where a human gives an LLM an input, the LLM performs an action in an environment, it gets some feedback, and then it decides when to stop. That's all an agent is. All of this stuff is a little bit hard to grasp with just this diagram, so let's dive straight into the code to see how this works. So here's a quick agent that I built in TypeScript. Now, for the sake of this video, I'm just using the AI SDK, and I want to highlight that really all the code that you see is just a wrapper around fetch. So LLM calls are just calls to an API. They're not a thing really, really fancy. All of this is just basically a wrapper around a fetch call. So if we look here, we have this generate random number agent. And the agent has a system prompt, which is just sort of the general instructions that it follows no matter what request it gets. And it says you're an agent that generates random numbers. Your goal is to find a random number that's both under 100 and even. So cool. Anytime that we prompt this LLM, we know that it's going to have the goal of giving the user back a number that is under 100 and is even. So if you look here, we give this fetch a set of tools. Now, this set of tools is our environment, as you saw in this little diagram. And I'll explain a little bit more about that later. For the models, we're just using GPT 3.5 Turbo because it's super cheap. And for the sake of this, we don't really need anything fancier. So here's the prompt that we have. It's just give me a random number. If you've ever used ChatGPT or T3 Chat, this is the thing that you put into the text box. And what we do with it is we just make a call to OpenAI or whatever LLM that you're using that generates some text. We just send it a message. And these tools are the environment in that these are the things that the LLM can do, right? So if we go back to this graphic, a user gives an LLM a set of instructions and an LLM takes action in the environment. In this case, that action is to generate a random number. So we say, hey, generate us a random number. And then the LLM responds saying, okay, I need to use the random number generator. And then we actually just get this message back, right? So this is just one fetch call. How does the looping happen? How does this, LLM perform another step? Where does that happen? Well, in order to do that, what you can do is you can store all the messages that you get back from this LLM in an array. So that's what we do here. We just print this out just so you can see it. And we store all of these messages in the array. And then we just prompt it over and over and over again until it repeats our task. Simple as that. That's how our loop happens. So we make a request to the LLM calls our tool and generates a number. And then we make another request to the LLM saying, hey, was that number correct? And then if it wasn't, we don't stop. We just keep looping until it's done. So that's our sort of action environment feedback loop. And actually, this one is simple, so we can just run this immediately to give you a demo. So you can see here, we have a prompt, give me a random number. And the first number it generates is 170. And it says, well, this isn't under 100. So I need to generate a new number. And then it generates another number. And since it's a valid number, it says found, and it's all done. Congrats, you built your first agent. So let's talk a little bit more about web agents. So web agents follow the same exact loop, except pieces are a little bit different. So for a web agent, you have a prompt like find the current weather in Vienna, Austria for today's date. And you have your LLM, which can be Claude, you know, GPT-4o, it can be really anything. And your environment is the browser, right? So you can use something like browser-based or Scrappy Bar. You can also run this locally with your own Chromium instance, all that fun stuff. Now, your actions are a little bit different. In our first example, the action was just to generate a random number. But in this example, you have 3 general actions that a web agent always takes, which is to click, to type, and to scroll. That's pretty much all they do. The feedback that you get is things like a screenshot. So a lot of these web agents use vision models. And so you send back a screenshot to the vision model and it figures out what to do next. You can also use the DOM tree for this, and I'll explain that a little bit more later. And also, every time you perform an action, you get the status of that action. And an action, again, is really just a call to this tool, and tool is just a bunch of TypeScript that you define. So whenever you perform an action, if it doesn't throw an error in here, it's successful. And so you make another call to the LLM, basically saying that you've done that action. And your result is obviously the weather. So again, a web agent will loop and loop and loop. It will use things like the screenshots that it's got. It will use things like the DOM tree, and it will just sort of say, hey, am I done with my task? And if it's done, it will stop. So yeah, that's just a basic web agent. And again, let's go look at this in some amount of code. Before that though, I want to show you a simplified version of this random number agent so that the next example I show you is a little better. So this is a simplified version of the agent. You can see we've gone from using a while loop to using max steps. So the Vercel AI SDK has this option that you can set where you set the max amount of loops that the agent will perform before stopping. Also, just as a side note, I know that things like master and other stuff exists. For the sake of this, again, I want to really highlight that a lot of these tools are just wrappers around fetch, and they're wrappers for a good reason. A lot of this is very annoying to manage, but I just want to kind of like hammer home how simple this stuff can be when you strip all of the like fancy language away from it. Okay, so let's go look at a very basic web agent. Now for this example, we're using a service called Scrappy Bar. I'm also going to demo a few other different types, but for this example, we're using Scrappy Bar. And you can see that this code looks very similar to the simplified agent, right? So we have our model, we have our tools, which is a computer tool, and I'll explain a bit more about that later. We have our system prompt, which is just a ton of language for OpenAI's computer use agent that Scrappy Bar has sort of figured out is the best prompt. And then we have our prompt. So we want to go to Google, find the current weather in Vienna, Austria for today's date, and then we'll print that result. And just so that we can see the browser afterwards, we have set this timeout here. So let's go give this a run. Should open up browser. So now you can see here's our Scrappy Bar instance. And you can see it's going to type in current weather in Vienna, Austria. And it's going to hit enter. And then it's going to look at the screen, taking a screenshot. In a few seconds, takes a second sometimes. We have our result. So you can see here, it's 9 a.m. in Vienna, and yep, Saturday at 9 a.m. It's 37 degrees with light rain. All the information is accurate, so it extracted it properly. So that's just one example of a web agent. And if we dive a little bit deeper into how that works, right, just to give you a little bit more information on this loop, again, it's the simple loop. We give the LLM a prompt. In this case, the model is the computer use agent that just got released from OpenAI. We have our actions, and Scrappybar's computer tool has a few actions like taking a screenshot, getting cursor position, moving the mouse, all that fun stuff. We have our browser instance that Scrappybar also provides for us. And then the feedback is sending back screenshots to the LLM or cursor position, or if the action completed. And just to break down what the LLM did here, it said, okay, I want to find this prompt. And generally the first thing it does, it doesn't always do this, but generally, the first thing it does is it takes a screenshot and then it analyzes that screenshot. It says, okay, what's there? Well, it's blank. So in order to complete my task, I need to go to google.com to find the weather. In this case, google.com comes by default with Chrome, so it doesn't need to search it. It just goes ahead and does it. Then it takes another screenshot and says, okay, what do I need to do next? I'm on google.com, search bar is focused so I can type. All right, well, I'm going to type in weather in Vienna, Austria and click enter. Okay, now I need to, check if the results have loaded, and it takes another screenshot and the results have loaded. So it returns the results. Pretty simple loop. That's generally what it does and how it thinks about it. If you want OpenAI's official loop diagram here, you can see that the task is text. You give it to the computer use agent. It does a bunch of actions onto the virtual machine. Once those actions are done, it takes a screenshot, returns it, and then does that loop until it's completed its task. So now let's go look at something like stagehand, which is a little bit different, and I'm going to explain that. So first, let's hop into the code. And you can see that stagehand is also extremely simple, but it has this act, it has this extract. And you're like, well, is this still an agent? Because it's kind of a workflow in that you want to first go and do everything, and then you want to extract stuff. Well, yes, because under the hood, this is still doing that same loop to do all of the actions. It's just separated the act and extract steps. Okay. So if we look here, same loop, send a prompt. In this case, we're using Claude Sonnet. And the actions are a little different because stagehand is built on top of Playwright. So in theory, your set of actions that you can do are any method that Playwright has. It's actually a limited set of methods that stagehand supports, but because it sits on top of Playwright, that's the theory of it. So you send a request to an LLM. An LLM goes and reads the entire DOM tree, and I'll explain that in just a second. It figures out what Playwright code it needs to generate. It generates that code. It applies it to the browser-based instance, and then it does that loop until it's completed. So yeah, as I mentioned 2 seconds ago, stagehand is built on Playwright. And this is an important distinction for 2 reasons. The first reason is that all of the actions, again, are Playwright methods. And the second reason is because stagehand has an option for vision, but by default uses the DOM elements in order to figure out what actions it wants to take. So unlike Scrappybar and the OpenAI computer use agent, which takes a bunch of screenshots and then figures out where it wants to click, this uses all of the DOM elements. So it will go and it will pull chunks, because web pages can be really big. It will pull chunks of the DOM out. It will analyze them, and it will say, oh, this is an input that might help me complete my task, and it will do that. It also doesn't look at every single DOM element. It uses a specific subset, things like inputs, links to other different things, and a few other HTML elements. It limits it to that, but that's how it works. So again, same loop. You give a task to the LLM. The LLM goes and pulls the DOM for the browser instance. And then it says, okay, does this DOM relate to what I was doing? If yes, click on it. If no, go to the next chunk. Is there a DOM here that relates to it? And et cetera, until it's done. So let's give that a quick run. Stage and so you can see here, we have loaded google.com. We are Googling weather in Vienna, Austria today, and it's performing all of its actions. And now the extraction should be done. So you can see here, okay, the weather is 3 degrees Celsius, 60% precipitation, all of that fun stuff. Now, the extract I didn't really talk about, but it's a much simpler loop. Basically, it goes and it finds all the DOM elements that might be relevant and extracts them. So just as a quick review, you can see our prompt. We send a request to the LM. We say, I need to get the weather for today in Vienna, Austria. We get a chunk of DOM elements. The LM says, oh, this doesn't contain the actions I need. I need to get more chunks. This chunk of DOM elements does contain the actions I need. So type in google.com. And then it sends another prompt that just asks the LLM, have I completed my task? And the LLM says, nope, I haven't. So it just repeats this until it's found everything. And then once it's done all the actions it thinks it needs to do, then we're obviously done with the act. And then we do another prompt to actually extract the information. And extract again is just done through looking at the DOM elements. Okay, now that we've seen Scrappy Bar and the computer use agent and now stagehand, I want to just give you a quick example of another model called ProxyLite, because it has this very cool thing that sort of highlights how vision models find the elements that it needs. So if we look here, I gave it a prompt, find today's weather in Vienna, Austria. And if we go look in the CLI, it has a different loop, which is just that first it observes the screen, then it thinks, and then it does an action. So it's an extra step into the loop, but it largely works the same way. And you can see here that we have all of these little highlighted elements. If we go to Excalibur, you can see them a little bit easier. You can see all of these little bounding boxes around a bunch of elements. So if you remember how I explained earlier that stagehand finds a bunch of candidate DOM elements, ProxyLite does the same thing, except it's a vision model. So it just highlights all of those elements so that the LM can find them a little bit easier. This is why ProxyLite can work fairly well as a 7 billion parameter model. So a very tiny model, it can work fairly well because it does all of this highlighting and is also fine-tuned a bit. So even though ProxyLite is a very small model, it's still very accurate. I found that other small models are not as accurate with DOM-based approaches. So I've tried stagehand with 4.0 mini, and it tends to be a little bit unreliable on this form I'm going to show you in just a second. And as one last example, here's an agent called Cura, and you can see that it has a slightly different loop in that it does a bunch of planning ahead of time. So you have a planner that figures out all the tasks that you want to do, which is the initial planner. And then you have the agent loop planner, which is mostly just the loop that we already have where you give this agent loop planner a task and you say, here's what should I do? You have an executor that executes the task. And so this executor generates maybe a bunch of playwright code or figures out what tool it needs to call in order to click on the browser and whatnot. Then you have a critic that analyzes if the task is done or if it's been done correctly. And then the agent loop planner goes back and figures out the next task it needs to do. So a similar loop, it's a little bit different. So yeah, these are the general approaches to building web agents that I found so far. I want to dive a little bit deeper into a specific example of what you can actually do with these agents, because we spent a lot of time in theory, and theory is cool, but I really care about building stuff. So let me give you an example of something I tried to build, and I'll explain how I actually ended up building it in later parts of the series. So I am a founder of a company called Seltzer.dev. As a part of being a founder of a company, you sometimes have to fill out very annoying paperwork, sometimes on a fairly regular basis. There are things like Delaware tax filings and keeping your company, all that fun stuff. It's very annoying and it's very repetitive, and I just wish something would automate it for me. And so I ran into one thing called the FinCEN BOI form. And usually I use a service called Clerky, and Clerky could automate this, but right now the API has actually been shut down for this. And so Clerky is not able to do it. Perfect opportunity for building a web agent to fill out this form for me and hopefully other people. So let's talk about why this specific form has tripped up a lot of LLMs, basically until about 5 days ago when better LLMs came out. So number one, if you look at it, it seems like a very simple form. I'll click initial report. type in your name. LLMs can do all that stuff very well. But there are a few UI elements that tend to trip up some agents that I've tried this form. So number one is this very fun input select combo. I think they call these com boxes. Um, so you have this thing, you can filter by typing, or you can click. What happens a lot of times is that an LLM goes and enters EIN into this and then doesn't really click away. What happens other times is that an agent will go and try to fill out this tax identification type and then end up filling the alternate name as the tax identification number. It's always very bizarre, and I'll demo a few things here. So here's the initial prompt that I tried when I tried building one of these things. And, it's file a BOI report for the following company. Here's a bunch of information. Don't skip over fields, scroll down before running to the next step. So let's give that a shot. So again, here we've loaded the browser. We have this modal that pops up. Stagehand, which is what I tried this with initially, has been pretty good about dealing with modals. And we just went back for some reason. I have no idea why. This has failed in very inconsistent ways constantly. I genuinely don't know. If I give this another try, I'll just run this again to try to show you the input bug I ran into last time. Load Chrome. And we click the modal. Cool. And now, again, we just click file BOR. And I think that's because it doesn't realize it's actually on the form that it needs to be on, and then it just fails. Also, this prompt is bad because of the formatting. I don't know why, but the white space in this sort of text formatting just does not work well. Weird lesson to learn. So let's try this now with a better prompt. And this is a pretty good prompt. You can see that there's not a ton of white space. Everything's collapsed, all that fun stuff. Okay. So we've loaded the page. And now, oh, I guess we're just failing again. That shows you how inconsistent these things are. Okay. So, okay. Sometimes that works and sometimes that doesn't. I think that's why I have this commented out example where this actually ends up being better, because I think I tell it to go to a very specific page and then I test that, but actually I have a much better example for that. So let's go here. So the third thing I tried, and this becomes more reliable, is narrowing everything down. So you have this thing and you say, okay, click on this very specific thing, click on this very specific thing, and then do this and then do that. And so if I demo that for you, you can see that we loaded the page, we clicked on the modal, and now we scroll down, we try to find the DOM element that's required for this, and we click on reporting company, and then I believe we were just filling out the tax ID for this, so we try to find where the tax ID is. And the reason why this scrolls, by the way, I mentioned Stagehand earlier, is a DOM-based approach. I believe it still scrolls just to load anything that is potentially not loaded on the page. So hard to see here, but I'll give this a little scroll. You can see that we filled out the tax identification type correctly. And now, in just a few moments, we'll fill out the tax identification number properly as well. Cool. So now the LLM has accomplished its task properly. Sometimes it has a hard time figuring out if it's done everything properly and it tends to loop. I don't know if it'll do it here, but just something to note. Nope. In this case, it stops. So that's an example of narrowing everything down. But the problem with this is just that it's not really agentic anymore. It becomes more of a workflow that has agents in it, but it's not like giving it an agent a task and then it just completes everything end to end. So yeah, that's not the utopia we want. So let's try this again with Proxylite, which is a smaller model, but maybe it will work a little bit better for these general tasks because it's vision-based. Over here, we'll take this prompt. and we'll submit our task. You can see here that the formatting is a little bit weird because of the size of the browser. Not really a way to get around this. We can watch the task happen in here. So you can see we get a bunch of logic. We know that we need to click the modal. And now we've clicked the modal. We observe everything. And we select initial report. So far, so good. I will say that from my testing, this is pretty inconsistent, to be honest. So it doesn't happen like this every time. So it's a rare treat to be able to see it. But you can see as well that it's just a lot more accurate, even though it's a very small model. Again, 7 billion parameters, pretty tiny. But so far, it's followed all of our steps properly. You can see that we've entered a fake company name. And you can see we've selected the EIN. Okay, so as you can see here, it fills out the tax identification type and the tax identification number. I decided to stop it because honestly, that's good enough. This model tends to be pretty accurate for these types of tasks. It's a little bit less accurate for other types of tasks, again, because it's relying on these labels super, super heavily. If I were to give this something like an Airtable table, it has a very hard time because it doesn't tend to label those elements properly. But it works here. It's a rare treat for it to work this consistently. And so again, that shows you like how weird the prompting can be for this as well. Even things like formatting matter a ton. And vision-based approaches, even with smaller models, just tend to work really, really well. I think that they're kind of the future. I wanted to do a quick demo of how Scrappy Bar works. We're going to use this old kind of bad prompt, but I'll show you the important reason why I think building applications for this are going to be like very necessary and the type of application I want to build. Okay, so here's an example of Scrappy Bar. So again, you can see that old prompt. We launch a browser, and if we tap back over, it says, hey, this task involves sensitive information. It would be more appropriate if the user completes a submission. Would you like me to guide you through the steps? So obviously it has a bunch of guardrails, and sometimes those guardrails are really hard to get around with prompts. So again, we have this thing, go to this file, lean report, fill out all this information, but the OpenAI computer use agent is sometimes limited in the thing that it's allowed to do. This is a part of the system card. It should show up somewhere when I edit this video or article. So in order to get around some of these parts, especially when OpenAI asks the user for approval, we kind of need to build a service that does something like, emails a user with a screen recording or a live view of what the browser is doing so we can approve or deny or change anything that's going on. I think that's just really, really cool. And it's also useful, right? I want to be able to farm a task out to an agent, have it email me, potentially do it overnight so I can wake up in the morning, look at the email, approve it, and move on with my day. So in order to do something like that, let's go look at a small service that I built to try to achieve that. Okay, so here's a small service that I made. It takes our company name and EIN, and then it's just going to go try to submit all of this stuff. So let's get started. We'll put in our company name and I'll put in a tax ID. And then I'll go give you a small overview of the code. So this is just a Next.js app. You can see here, we've got a bunch of stuff. We submit it, but I'll kind of cover the workflow code here because this is Restate. This is our workflow provider. It's really, really cool. I could go into a whole deep dive about it, but what it allows you to do is it allows you to pause and sleep the execution of your workflow. And so you don't have to use resources like Lambda or Vercel. You don't have to pay for that compute time if your workflow is waiting on a user to go and click on a button to approve it. And we'll cover a bit of that code here. So this is the workflow code. And basically what we do is, we set our status to running. We run the initial part of the workflow. We take the current URL and we sleep for 35 seconds, and then we reconnect and confirm. This sleep here is trying to represent what it would be like to basically wait for a user to click on an email. And then we run this next step. So What we really want in an ideal world is for us to have this workflow, for whatever handles this workflow to be able to shut down, right? So let's say, we're running this on Vercel, and let's say the user doesn't respond within the 15-minute timeout window that Vercel has for their functions. We should be able to pick up on another function and just continue going, because that means everything is stateless except for our browser instance, which lives on browser base or Scrappy Barra. And it makes the state management a lot easier because the state generally lives in this workflow. And we just sort of pick it up, connect to it, and do whatever we want. Those of you who know a bit about browser automations kind of know the complaint I'm about to surface here. So um, let's just go and give this a try. And this is a little bit of like a intentional demo, um, just to show you the plan I'm trying to make here. So I need to add a bunch of random numbers to this because it's idempotent. Okay, so we have our company and it's called test. We're going to submit our BOI information. And now, just to simulate what it would actually be like, you can see that we are starting to run our thing here, starting to run our workflow. I did query again. And it's basically spinning up a browser-based instance in the background of this, which I can show you. So in the background, it's spinning up a browser-based instance. You can see that this instance is gone. It's starting to fill out the form, all that fun stuff. And I'm just querying this a bunch so that we can see when the form falls asleep after it's done running its initial workflow. So it looks like, okay, lovely. So it looks like our workflow is now done and it's now asleep. So because it's asleep, we're going to kill our Next.js server, which again, for the sake of this demo, happens because this workflow is going to sleep for 35 seconds. Yes, I understand that Vercel has a function that lives for 15 minutes. Besides the point, we're going to kill the server to pretend as if that request is now moved on and the connection between Playwright or the connection between Stagehand and our browser is no longer there. Now, if we look, and we give that a refresh, you can see the session is completed. And you're like, why is it completed? We need to start our server back up so we can continue this workflow. So we start the server. This is going to pick up where it left off. Q. And if you look, you can see we get this error, WebSocket error, and it could not find a session with this ID. And you're like, what's going on? And sorry, I was like, what's going on? Because this is me going to develop this and I hit a weird wall doing this. If you look in the documentation for Browserbase, you can see that sessions terminate in a few different ways. And I didn't know this before I was implementing everything. One is automatic timeout. You can fix that with keep alive. The second one is manual termination. So if you do browser.close or driver.quit, browser.close is the playwright implementation and .quit is the Puppeteer implementation of that kind of thing. It releases the API. And the third one is unhandled errors. So errors in your automation code can cause your script to disconnect from the browser, ending the session prematurely. Scenarios include network interruptions, uncaught exceptions, or exceeded resource limits. So make sure you clean up errors and you implement proper error handling. And I was very confused. I was like, well, this is kind of odd. I feel like I should just be able to connect and reconnect. This makes it a little bit tougher to implement serverless stuff. So I did a bunch of research. And the first thought was, well, maybe this provider doesn't do it. Maybe another one does. So I went to Cloudflare and I looked, and you can see largely the same thing. Cloudflare is a little bit different. They have their own Puppeteer implementation. So what you can do is you can disconnect, and then instead of doing close, and then you can reuse the browser session. But the session is not the thing we want to reuse. We actually want to reuse that tab. Unfortunately, it's not really possible. Both Puppeteer and Playwright are built on top of something called CDP, the Chrome DevTools protocol. This protocol is the thing that allows Puppeteer or Playwright to be able to send commands and messages to the browser in order to do things. But this protocol is only one, it only happens in one direction, right? So when Puppeteer sends requests, it gets responses from the browser, but the browser can't really send requests or send messages to Puppeteer in order to inform its state. So in a very odd, backwards, like unintuitive way, the state of your automation does not actually live in the browser. It lives with Puppeteer or Playwright. And this is kind of a good thing for those two tools because they're testing tools. Whenever you're using Puppeteer or Playwright, you actually want them to control the state of your browser because that ensures that your tests are deterministic. So actually, Playwright, every time you make a new connection over CDP or you launch a new browser, it actually creates a brand new context, which is just a Chrome profile. So if you do, open an incognito tab, this is a new browser context. And you can manage all those tabs during that session, but when you disconnect the WebSocket connection from Playwright to the browser, that context is essentially lost. Even if the browser is still there and it has the tab open, you can't reconnect over CDP again and manage it. Very confusing, very unintuitive. Trust me, I looked for a solution to this, but one doesn't exist except for something called Web BiDi. And it's not BIDI, it's BiDi because it stands for bidirectional. And you can see here it's the future of cross browser automation. This is a very good thing to read and listen to. It talks about WebDriver, which is the OG way of doing browser automation, and CDP, and sort of talks about what BiDi is here for. This Selenium article is also very good. And basically, the entire point is that you now have these things called BiDi sessions, which are just things where whenever you connect an automation tool to a browser, the browser now holds information about what that automation was doing to make it a little bit easier to send commands in both directions. So now our browser can send a message over to the automation tool to tell it its existing state. And it can do this over HTTP as well, which is very nice. Right now, the existing connections to the browser for CDP at least are over a WebSocket. BiDi is still early though. So here's a WebDriver BiDi. This is the W3C organization. They're the people doing the standard for this. It's still a little bit early. This is something from 4 years ago. I believe it's been resolved now, but I'm not fully sure. What happens if a socket dies prematurely? This is pretty much the question that we're having right now is if I disconnect the WebSocket, what happens? And they haven't fully decided yet. And one of the people managing or contributing to BiDi says simplify the spec, by not supporting reconnection within a single session on the basis that the implementation complexity isn't worth it for the number of use cases it serves. So I'm not sure any of these three options have been decided on yet. I hope 2 or 1, which is have a buffer of events. So when you disconnect the browser from the automation tool, the browser holds this buffer of events that are happening, and then it sends them whenever the reconnection happens. That would be pretty cool. I actually had an idea about that. So to further break down how CDP works, basically it's this protocol that sends messages over WebSockets using JSON. You can send a request like go to this page from Playwright to the browser. And when that happens, the browser responds with, the status of it doing that action. So we'll do that action and then respond. Sometimes though, you set these certain, like Playwright will send these certain requests so that when events happen, the browser will send a message back to Playwright. Things like, hey, monitor the network for any events that happen, or monitor the console. So anytime something gets printed to the console, the browser will send a message to Playwright over WebSockets using CDP saying, hey, I've just received something on the console. Here's what it is. So obviously when those two things disconnect, right now all the messages are just lost because they get sent into the void. But in the future, Chrome could just hold a buffer of those messages, and then when the reconnection happens, the automation tool will get those messages afterwards. Okay, very long, deep explanation of this. This is maybe a week's worth of like me thinking about various different ways to solve this, and it's just doing everything at the Playwright level is just honestly not that great. Playwright is a testing tool. It's really designed for that. It's good in a lot of ways, but this is not the right layer to do things. And let me sort of expand on what I mean by that. So I just went into like a deep dive of CDP and why it's not really the right solution for this and why BiDi coming is going to be good. But if you really think about this problem, if you step back, you have these three actors here. So one of them is, let me make these squares a bit smaller. One of them is the user. Okay. So the user is the person sending all these requests. One of them is your workflow engine slash workflow handler. I'll put those two things together because for the sake of this, it doesn't matter to me. And the other thing is your browser instance. So right now we have the limitation that Playwright cannot disconnect from Chrome, right? That is our limitation. And so obviously any sort of service that doesn't allow long running tasks is not going to work for us. So we have our browser instance, we have our workflow engine and handler, and we have our user. We know that Playwright cannot disconnect from Chrome. So let's think about the way that we're going to like build this system here. So we have all of these three parts. So your browser instance, ideally, you don't really want to handle this yourself, at least from the get-go. So let's just make this an external thing for now. And we also know that Playwright can't really disconnect from Chrome. And we want to have this sort of like serverless experience because that makes it a lot easier. So I don't know. Let's do this. If we're using something like Cloudflare, right? So we'll put in Cloudflare and we'll make this orange. I think that's brown actually, but it's my screen has a filter on top. So if we're using something like Cloudflare, Cloudflare has this really great primitive called durable objects. And what a durable object is a long running stateful server that runs on Cloudflare workers. And that's great. That sounds like basically exactly what we need. We need it to be long running because obviously we want these things to last so that the connection from Playwright to the browser doesn't expire. And we need it to have some amount of statefulness so that anytime we're doing things with our workflows, like seeing what step it's on, we're not having things rerunning. We can do retries, all that fun stuff. So this seems kind of perfect. We have an LLM, we have a browser, but then we also just explained that in order to have actions happen, we have to have the CDP connection. So we have a workflow engine here, and our CDP connection lives here, and our LLM and other stuff lives here. So that's pretty great. The limit with Cloudflare is that if you do this, it's all on V8. So Cloudflare workers don't actually run JavaScript, or excuse me, Cloudflare workers don't actually run Node.js. They run something called V8 isolates, exactly the same as the runtime in your browser. And they have some Node.js compatibility things, but one of the frustrating things is that one, Node.js compatibility just isn't there, so you can't do things like read and write files. And two, it doesn't support Playwright. So we actually can't use things like stagehand for this. And actually, funnily enough, browser-based and Cloudflare durable objects can't connect to each other for some interesting reason. So using anything browser-based related is just a no-go. So I'll put like a kind of a big no Playwright because Playwright requires file system. So we're basically limited to using Puppeteer and only like you're very limited to Cloudflare browser rendering. So I think for the most part, this will work well. For my use cases, it doesn't because I actually wanted to be able to run a service like this or any web agent I built in a user's VPC on something like AWS. I think that's very important to like be very flexible with where I can deploy stuff like this. So for my use cases, it doesn't exactly work well. So let's think about another solution, which is Um, we'll mark this green and we'll say uh, your own set of infra. So again, we can't use Cloudflare, and we still need this workflow handler. We still need a workflow engine, and we still have our browser instance. Let's say this time we're using browser base. Well, I can't use durable objects, and I still need something stateful. So I don't know. Let's do something like um, an ECS instance. And so our CDP lives here on ECS. And let's also make our workflow engine live there as well. Fine. And now we have our workflow handler. This can live in something like Lambda for the LLM. And you actually can make all of this live in one box if you wanted to. So like if I were to simplify all of it, okay. If I were to simplify all of this down, I could say that our workflow handler also lives in the same place that our workflow engine and our CDP connection lives. And so we make calls to Lambda and we sleep and all of that fun stuff in one box. And we might actually have another service like the service that I showed you earlier, which is Restate. So Restate is like our workflow engine. Okay, so now we have this better set of things running on your own infra. And you can see like my initial thought here, which is like to run all this on ECS. And then, we're now using Restate as our workflow engine. And so this is kind of like the simplest architecture that you can have. With like, you have one box that's basically handling all of your calls to the LLM, and it's also holding the CDP connection. But that's kind of hard, right? Like, what happens if you don't handle an error properly here and then it destroys your CDP connection? It's kind of annoying. You can do error handling properly. I generally want to separate these things, but all good. This is simple. Not as satisfying for me, but simple enough. But the kind of annoying thing is that I'm having to manage this entire instance that I'm running. I have to make sure that like upgrade it properly. And, if I push code to it, well, that means that this box won't get updated to the new code until it dies and all of that fun stuff. And I'm also paying for this box here, right? Like I'm paying money to have a browser instance, and I'm also paying money to have a long running server. And the workflow engine is honestly pretty cheap, but that's kind of annoying to have to pay for two boxes. So your own set of infra, like the worst part about this, downsides, you are always paying for two servers, which just irks me a lot. Doesn't matter how simple you make all of this, like you are always paying for two servers. And that's kind of a bummer. So my big plea for infrastructure providers is to make it so that you do not need to have this CDP connection live on a separate box. And what does that mean is that basically Playwright should live on the browser instance and not with me. So the ideal world is that the CDP connection lives here and you can make action requests to this box. And so now this doesn't have to be a box at all. It can be a Lambda. It can be whatever you want. It's so much simpler, like to a comical degree. And I know this just sounds like a Next.js person complaining that they have to run a server. And honestly, it is, but it just makes everything way, way, way simpler. You can run all of this statelessly. So Restate, I don't have to worry about deploying that. So in an ideal world, My workflow handler and all the code that I run remain stateless. This browser instance that I'm paying a lot of money for, the connection should live there, and I should just be able to send these sort of action requests to this box. Let me explain another reason why this ideal world is so important. Let's say that you wanted to build your own web agent from the ground up, right? And you wanted to use the AI SDK to do it. Well, you need to follow this loop. You would have a set of actions, you'd have a browser and all that fun stuff. But one of the nice things about having a browser instance that has a generic set of endpoints that you can do actions on top of is that the format in which you request, uh, the format in which you build these tools becomes a lot easier. So right now, if you wanted to build your own set of tools to do stuff, you'd have to write this part out, which is not too bad. All this would do is just make a request out to your API endpoint. You'd have to take that, however, and translate it down into whatever actions you wanted to do. And then you'd send that to the browser instance. So again, you're paying for two servers and now you're having to write all of this code yourself. The thing is, though, is that if we go all the way back to the beginning, most web agents do three things. They click, they type, and they scroll. If you look at a bunch of papers, and trust me, I've read a bunch of them, most of the actions revolve around this kind of thing. But the thing is that a lot of them tend to like change the format or a description for the tools that they call. So sometimes you have a computer tool like this, or sorry, sometimes you might have a scroll tool, and you might have like a scroll halfway tool because the people building models determine that a scroll halfway tool is needed for better interactions. And so now you have to build all of these layers yourself, right? I need to take the scroll down halfway tool. I need to make sure it works properly on all of my stuff. I can't really just like swap out a model to make it work, right? Because I don't have these generic set of tools and generic set of endpoints that I can just work with. I'm having to roll all of the infrastructure myself, even though, again, the reaction types, click, type, scroll. But again, if we go back, just to highlight my point, please, if you're an infrastructure provider, anything that's stateful should be pushed onto you. Generally, like the best way for developers to develop applications is in a very stateless way. It allows you to move very, very quickly. It's just honestly like a really fantastic developer experience. There's a reason why Vercel is so popular. There's a reason why Lambda is so popular. Stateless stuff is great. However, if a developer does have to manage state, that generally should live with the provider as much as possible. And I'll give you an example of like people adopting this pattern more and more. And OpenAI is a great example. So a few days ago, they released something called the Responses API. And what it does is that if we go back to our very, very basic web agent, we need to go to this one. You can see that every time we get a message from the LLM, we need to add that to our messages array so that we can send it back into the request so that we can continue the loop while the LLM knows its sort of history of messages that happened, right? And this state is all stuff that you have to manage yourself. If you had 100 message long chain of things, you would have to figure out a way to store that to make sure it works properly. Let's say, again, this is baked into a part of a larger workflow where this agent is doing something. You need to make sure that, if the agent sleeps for a while, when it wakes up, it has all this memory. Like, it's just really annoying to do. And you have to figure all of it out yourself, or the provider can do it for you. You have this thing, you have these set of requests. And anytime you send a request, you get a responses ID back. And when you pass in the previous response ID, it gets the entire message chain of stuff that you sent to it. Again, another example of the provider just managing the conversation state for you, because that's what good providers should do. They should manage as much of the state as they can. Think about Lambda, right? Are you managing the orchestration of the EC2 box that your code is running on top of? Making sure that if you roll out an update to this fleet of Lambdas that, the Lambdas that are currently running are not shut down. Are you sort of figuring out how to scale it? No. And all of that is a state problem that has just been pushed onto the very smart engineers at AWS, right? So if you're a provider and people are paying you tons of money to be able to host something like a browser instance, please manage the state. It makes everything a lot easier. I'm begging you, please do it. The amount of time I spent thinking about this is way too much. I'm sick of it. Anyway, okay. This is going to be now a rant about a provider that does this properly called Scrappy Bar. I've demoed a little bit of this stuff before. They have this great article called Unifying the Computer Use Action Space, where they sort of cover how annoying it's been for them to do things like handle Claude's left click to behave like UiTar's click. And it's just like kind of annoying for them to manage all of it. It makes it really hard to swap between models. So they built something called a computer endpoint, which does move mouse, click mouse, drag mouse, all as an API endpoint, which is amazing. It like I cannot tell you how much easier this makes everything. It makes everything so easy because now if you wanted to roll your own set of tools, you can do so very easily by just pinging this API endpoint. Or the nice part is that they have a really cool Act SDK that I showed off earlier that has all of these tools for you right here. So you can see here with their Act SDK, it's just like one line of code to add all of the tools that a model needs to be able to work properly. Like I genuinely cannot tell you how much easier this makes everything. So, all right, let's summarize everything because we're coming up to the end of this video. Um, Agents, like they're really getting to a place where they're becoming very good. In the next video, I'm going to show off how I built a service around this to be able to file a form, to send a user an email, and to do this entire process. But um, kind of my biggest tips are the following. Number one, use a really good model. Um, I didn't demo this earlier, but something like 4.0 mini performs significantly worse than 4.0. If you're doing DOM processing, especially, like use the best model possible. And um, if you're doing like vision-based processing, I would still use probably the best model out there because its ability to figure out what to do next, its reasoning is just a lot better. The second thing is in terms of building all the infrastructure and like building the actual product for this. Um, Honestly, my advice my advice is use Scrappy Bar. It's generally very good. They have a fantastic playground. Like their pricing is very fair. Um, and I love products that have good pricing. Like I could go an entire rant about pricing. I'm not even kidding. I've done it before. Um, they have a really cool playground, which I'm trying to find here. It's very nice. Mm, if you do need to do stuff on your own, browser based is also a good solution. Just know what you're getting into. You're going to have to run that second server yourself if you have long running tasks. If you have short running tasks or things that need a proxy, browser based is a great solution. They're also SOC 2 and HIPAA compliant, which I'm sure Scrappy Bar will catch on to. And what else? I think that about covers it. Yeah, cool. Thanks for watching. Fuck.